All right, so I got two groups. As a general rule, t-test, it's not always true. More than two groups, I got an ANOVA. Well, we looked at correlations before. Now, in a correlation, it's rare, really rare to have a linear increase. So it's really rare for an increase in one variable to be met with the same proportional increase. It is really rare to get something that looks like that. Is rare. What you normally get are data that are all over the place. That's typical. So it's rare to get an easy linear correlation. And remember, Mill was like, look for concatenate variations. All right, I looked for concatenate variations, and that's what popped out. This is not clean. Well, there are statistics that one can use for this. What we're going to look for is what's known as the correlation coefficient. And this is going to tell me the strength of the relationship between the two variables and the direction. Once I get my correlation coefficient, I can then do something else. I've got this spread of my data. It's not in a straight line. I can find a line that helps me best predict this data. That is, I can make the line. And of course, there's a statistical technique for that we can learn. So we can make a regression line. Now, remember, Mill said, look for concatenate variation. Well, that's easy if the data are all in a straight line. But if they're messy, you got to do something else. You have to do statistics. And this is why that class is so important. And so when it's taught so that y'all don't remember anything, I sadly die a little inside. A little part of my soul disappears. So we have t-test, if I have two variables, generally. ANOVA, more than two, and then maybe follow-up t-tests. If I'm looking at data like that I'm looking for a relationship between two variables, I'm often going to do a correlation, where I need to find the strength of the relationship, and I might get a regression line that allows me to make the best prediction. So that's really what I'm trying to do here. Any questions before I'm going to show you this one. I'm going to show you examples of this one. All right, so let me give you some examples. So why not start with baboons? I always try to start with an example that no one's like, oh yeah, what's he going to give as an example for this one? It's, baboons. There's some baboons, and they are pushing each other. Pushing is a nice old word to mean look for vermin. So they're sitting there looking for vermin on top of each other. And what's interesting in baboons is that the mother's rank, that is the status of the mother, is positively correlated with the status of the daughter. So if we plot the data, so it takes a second to see what they've done here. They put the highest ranking people here, so it's like this is the highest ranking, they're first, second, third, fourth, fifth, and the lowest ranking, and they've done the same for the kids. But we still get this nice positive correlation, though the data are all over the place. Remember the term for that data point there that didn't seem to be fitting? It's an outlier. So this was actually an infant that had been adopted by one of the old, by one of the mothers, by one of the high-ranking mothers. So we've got this data, and what we can do here is we can then plot a regression line that best explains this data. So we plot a regression line that best fits this data. And we can say, okay, this is the straight line, right? I mean, if I were to do it real fast, I'm not going to lower it and raise it down, but you can imagine drawing a straight line that best fits all this set of points. So then I could say, oh, this mother has a rank of 5. Well, where's her kid likely to be? I can then tell you the likely rank of their child. All right, let's say you're, think of correlation this way. The higher the correlation, that is, the higher the relationship between the two variables, the more accurately I can use one variable to predict the other. Right? If there's a high correlation between high school GPA and college GPA, I can then use your high school GPA to predict your college GPA. If there's a high relationship between the status of the mother and her infant, I can then use this to predict. That's why we're doing this. I want to be able to predict what the variable is going to be. Like if I know this variable, I want to predict this one. That's why we're doing these correlations. So if I know that height, in this one, if I know that weight and illness, so let's say that I find that body weight by BMI is correlated with the number of illnesses that one has, right? And you come in and you say, oh, Dr. Robinson, I'm right here. I can say, well, you know what? You're really putting yourself at risk for a lot of illnesses. You know, maybe if you drop some weight, help yourself out. I haven't had a chance to read the original article yet, so I probably shouldn't say this. Anyone see something that came out like a week and a half ago? They were basically arguing that this isn't as strong as people have said. Give you that for free. This doesn't mean go eat bonbons all weekend. It just means, you know, just so you don't look like a model, you're probably not going to die. Y'all aren't happy about that? All right, so what we get out of this is we get our correlation coefficient. If you remember, that's R. This, if it's positive or negative, tells me the direction. So if it's a positive, this is a positive relationship, so I would have R equals positive, or it wouldn't be marked at all. If it was a negative correlation, it would be R equals negative. And then I have a number that ranges from 0 to 1. It can't be higher than 1. Can't be lower than negative 1. But you're probably going to get a number like negative 0.39 or positive 0.24. And this is telling me the strength of the relationship, how well I can predict one variable from the other. If it's perfect, it's a 1, and you're probably not going to get it. If there's none, it's 0. And if it's perfect negative, it would be obviously negative 1. And what this means is, you can think a relationship of negative 0.62 is a stronger negative correlation than 0.23 is a positive correlation. Y'all are giving this look like, oh. Byron, I mean, like, seriously, whenever I teach statistics, I feel like there's this, it's like y'all want to hate it, and whenever there's a glimmer of insight, it's like, oh, you just stifle the glimmer of insight. So if you want to think about the strength of the relationship, there's a mathematical concept. The strength of the relationship is best represented by, see if you can remember or figure it out. Absolute value. Yeah, Russell's right. The absolute value helps with this one. So if you want to think of it as the strength of the relationship is the absolute value, the direction of the relationship is positive or negative. If you remember your absolute value symbols from before. Any questions about correlation? I'll give you one more correlation here. All right, see if we can use correlation. I don't know why my stuff isn't working today. So how would I show the importance of the spots on a peacock's tail? Right? One theory is the peacock has all these spots because the peacock is basically like, hey, peahen, look, I'm shaking my tail feathers, you know, like, right? This peahen is not particularly impressed. You know, he's sitting there going, look at me. How would I show that the number of spots actually matter? Well, one thing I could do is I could plot a correlation. The number of eye spots that a peacock has and the number of peahens who are like, shake your tail feather. Was that Nelly, P. Diddy, and some other guy? Have we figured that out yet? Nelly, I think it's Nelly, P. Diddy, and Murphy Lee. Oh, it is. That is the third person. I've been like, I got the first two. Who is the third? Murphy Lee, right? That song actually deeply bothers me. Not that I'm offended by the shaking the tail feather, but I'm like, women don't have tail feathers. And then I'll see like peacock Halloween costumes for women, and it kind of, I'm like, what is this cross-species thing going on? Cross-species, cross-gender, it deeply disturbs me. I'm like, oh my gosh, you're a female human acting like a male peacock. What I have issues. Other people are like, that's a cool costume. I'm like, you're not even the right species or gender. So I haven't proven that the peahens love the eye spots, but I've certainly given a suggestion of that, right? So there's a positive correlation. How might I, we're going to look ahead and see real examples of this, but how might I strengthen my argument that peahens really love the tail feathers? Even intuitively, if I want to see if that's really what's going on, well, couldn't I sort of take one peacock's tail feathers and cut them off? Oh, you're feeling bad for the peacock now, right? So if I'm right and I take a peacock and I snip, snip, remember I'm doing the method of difference. What might you imagine is going to happen to my peacock now?
And sad.
He's gonna die alone and sad. Yes, that's probably what's gonna happen. He's gonna be like, I had tail feathers at one time. What happened? All right. I'm gonna do the method of addition with my peacock buddy. What?
Add more.
Yeah, I might add more. I might find a particularly nerdy peacock. Maybe his tail feathers are a little bent. He's not really cool. And when I put him to sleep, and I glue a bunch of tail feathers to him, and he wakes up. And what did you say?
Give him like 220.
I'm gonna give him 220 spots. He wakes up, and he's like, "Women sure do love me. What's up, right?" And people have actually done that experiment, believe it or not. Really? You're feeling bad for the peacock? Right. All right. If we would stop this cross-species, cross-gender stuff, maybe we would not have to do this. Seriously, whenever I see it, I'm like, why don't males wear peacocks? That would make a lot more sense. But no, they're all designed for women. Alrighty. I hope he cuts that out of the online one, my ranting about Halloween costumes.
I don't know if we have to suffer through it. Maybe.
Suffer? I have let you into the crazy that is in me, where I look and I see costumes and go, yes, you're an attractive woman, but you bother me with your cross-species, cross-gendered costume. Put on something more, I don't know, would be appropriate, Like, let me wear that. Just take a second. If anybody's really good with Photoshop for the online people, Photoshop me and, dressed like a peacock.